So polar coordinates are fairly new to a lot of you, and so I think the graphing a polar coordinate, um, just a point, is probably not too bad. I think most of you can grasp that pretty easy. But graphing an entire equation is another thing. And so we kind of have to go back to the good old days when we used to draw the t-charts. And I think we'll start with that, but hopefully we'll move away from it before too long. So in this case, I have r, my independent variable is theta and my dependent variable is r. So I'm going to just start plugging in some angles and getting out some radiuses and see what happens, and just plot the points. So now this one's unique. We've done one of these before, but again, if you're showing the process, the idea is that no matter what I put in here, like 0, this says I get out 6. Or if I plug in pi over 4, that means I get out 6. If I plug in, I don't know, pi over 3, I get out 6. If I plug in 5 pi over 6, I get out 6. And so if we plot each one of those, 0 means I'm facing in the positive x-axis because I haven't turned it all. And I go out 1, 2, 3, 4, 5, 6. There's a dot. And if I'm facing in the pi over 4 direction, that would be right along here, right? No, it wouldn't. It'd be right along here. I missed one, right? Because that's halfway between the two axes. So I'd go out 1, 2, 3, 4, 5, 6. Maybe I should use some highlighting. So that's facing in, whoops. Yeah. If I'm facing in the 0 direction, it'd be that way. If I'm facing in the pi over 4 direction, it'd be that way. If I'm facing in the pi over 3 direction, that would be, let me use a different color. That would be right along that line, right? Make a smaller point here. There we go. So be right along that line. Okay. Crying out loud. If I'm facing in the 5 pi over 6, that'd be way over here somewhere, facing in that direction, right? And I'm going out 6 still. So that would be 1, 2, 3, 4, 5, 6. And so you can see that we don't have to do a bunch of these, but you can see no matter what direction I'm facing, I'm going out 6. So this produces a circle. And it looks like that. Similarly, in this one, this is an easy one too. This says theta is equal to 5. I'm going to leave that one because it's kind of like this. Let me jump down one that maybe is a little bit more challenging. Let's do this one. So r is equal to 6 cosine theta. So again, you're going to draw your little r theta t chart and start plugging in values like 0. When I plug in 0 in there, cosine of 0 is 1. So that means I start out, when I'm facing in the 0 direction, that would be facing out this way. My r value is 6 because cosine of 0 is 1, 1 times 6 is 6. So I go out 1, 2, 3, 4, 5, 6. Put a little dot there. Okay? Now, let's go to pi over 4. Okay, now when we say pi over 4, that means I'm facing in this direction right here, halfway between the x-axis and the y-axis. And when I take cosine of pi over 4, I know I get 1 over rad 2 times 6. That would be 6 over rad 2. Now that one's a little bit hard to know what that is, so grab your calculator and say, what's 6 divided by the square root of 2? And you get about 4.3-ish. So that means I'm going to go out 1, 2, 3, 4, and put a little dot right there. So that makes me think, well, maybe I need to figure out what happened in between there. So I'm going to go back and do a pi over 6. Now cosine of pi over 6 we know is rad 3 over 2 times 6. The 2 and the 6 cancel out, so that'd be 3 rad 3. And again, a lot of us don't know immediately off the top of our head what that is, so we'll take the square root of 3 times the square root of 3 on our calculator. And it's about 5.2-ish. So that means at rad 3, pi over 6, which would be right about there, I was at 5.2-ish. So I'm going to go out 1, 2, 3, 4, 5.2-ish. Now, the thing you have going for you is that you know that these things are created by a curve. In fact, these values are created by a circle. So you know there's a curving pattern to them, no matter what they look like. They're never going to be, I shouldn't say never, but most of the time, they're going to be if they're involving sine and cosine, they're going to have a curved pattern to them. So, and you want to do enough that you can see what's happening here. So you can see that as the angle is sweeping around in the positive direction, the radius is getting smaller. So what we see is this thing is getting smaller and smaller and smaller and smaller and smaller and smaller. The question is, how small does it get? Well, we know that cosine is going to go to 0, right? When does cosine hit 0? At pi over 2. So when I plug in pi over 2, I get 0. And that's the first time I get 0. So that means by the time I'm facing in this direction, I'm going out in that direction 0. So by the time I get to there, I'm back down to 0. So we have this nice curvy, and you can see, again, you can see those green lines getting shorter, right? Okay, so now what happens next? Well, let's think, instead of doing all this crazy plotting stuff, let's forget about that for a minute, and let's put a cosine curve in front of us, because you all took past Math 142, right? So you can, off the top of your head, draw a cosine curve, right? And we know that this is pi, this is pi over 2. And so we've just graphed essentially this part of it. I mean, we've got the values from that. So we know that on the as far as the cosine goes, these values are going to be just like those, only negative. So we're going to cover the same pattern here, only negative. So now be careful of this. So now as I face in this direction, and that direction, and that direction, and that direction, my radius is negative, and it's the same as this over here. So when I'm at, for example, here, I'd be back out to 6, but it's going to be negative 6. So when I'm facing this direction, notice it's going to come back to that point right there. And these values here, and again, notice this is supposed to be just growing and getting bigger, but it's a negative value. So what happens here is we actually end up going out. So on this one, I'm going to be going out in that direction. So it's going to be out here somewhere. And this one's going to go out in that direction. So it'll be out here somewhere, etc. And so what happens is we get this a mirror, a curve below the x-axis, because all these things, so if I was to draw, let me grab a blue, and I'm going to make it smaller. So the negative version of this would be out there, the negative version of that would be out there, and the negative version of that would be out there, and the negative version of that would be back out there. So you can see the blue lines growing as we go around back to the until it comes back to this point. Now from this point on, now from here on, I'm going to do the same thing I just did. So I'm going to go from negative 6 back up to 0. So now I'm in this quadrant, and I'm doing from negative 6, which would be right here, back down to 0. So notice it's going to cover the same exact graph again. And then from here, we're going to go from 0 back up to 6. But now we're in this quadrant. So it's going to, again, just cover this thing. It's going to go from 0 to 6 again. So what we find out is that this r equals 6 cosine theta ends up, let's erase all the highlighting. Hey, how come you're not erasing? It looks like that. But notice that this is important. What we're going to do next is that this whole entire graph was drawn just in the first 0 to pi. And from then on, it just repeats itself. So that's a kind of unique thing about that graph. Okay, well, there's a couple examples. This worksheet is on Canvas, so I want you guys to do your best at trying this, and I will post a video later of me. Well, at least I'll post the answers of this. I don't know if I'll get to a video. I'm making a lot of videos right now, so. But try your hand at it, see how it goes.